The concept of economic efficiency has intuitive appeal as a normative concept, because any efficient allocation is one where we can change the situation and make someone better off without making anyone else worse off. If we were at an inefficient allocation, we could make everybody better off. So being at an efficient allocation is something that seems desirable. But there are typically many efficient situations, and so economists often look for normative criteria to judge which of the efficient allocations is better than others. We'll begin the process of grappling with this in this graph. One way of confronting the underlying ideas is to return to the Edgeworth box of chapter 16. There, we assumed that we had two individuals who consume two different goods. There's no production in this economy, just trade between individuals. In panel A, we therefore construct the Edgeworth box again, and we begin with the indifference map for individual 1. Individual 2 is then graphed on a separate axis, which is flipped over and has its origin at the northeast corner. Recall that the dimensions of the Edgeworth box are such that any point within the Edgeworth box is a feasible allocation for this economy. In other words, we can choose any point and measure on the lower axis how much individual 1 is getting of each of the goods, and on the upper axis how much individual 2 is getting. When we then draw individual 2's magenta indifference map, we see that for every blue indifference curve, there's a magenta indifference curve that is tangent to it. In chapter 16, we illustrated that these tangencies are efficient allocations, allocations where it is not possible to make both individuals better off, or to make one better off without making the other worse off. We call the set of all efficient allocations in the Edgeworth box the contract curve, and the contract curve always has to extend from the lower left corner to the upper right corner. Notice that it's always efficient to give one individual all of the goods, because if one individual has all of the goods, there's no way to change the situation without making that individual worse off. In panel B of the graph, we'll now translate the points that lie on the contract curve into a graph that has the utility of individual 1 on the horizontal axis and the utility of individual 2 on the vertical axis. The allocation A in panel A, for instance, gives individual 1 utility level of 5 and individual 2 a utility level of 25, as indicated by the labels on the indifference curves that pass through the allocation A. The allocation B gives both individuals utility level of 18, putting us on the 45-degree line in panel B. And the allocation C gives individual 1 utility level of 25 and individual 2 a utility level of 5. Repeating this for all allocations on the contract curve in panel A then gives us the utility possibility frontier in panel B. If we're at any point on that utility possibility frontier, there's no way to make both individuals better off, or to make one individual better off without making another individual worse off. That's because the utility possibility frontier is derived from the set of efficient allocations in the Edgeworth box. We can now view the utility possibility frontier as a constraint that the society that's represented by the Edgeworth box faces. We can choose to locate inside the utility possibility frontier, but if we do so, we're giving up the possibility of making both individuals better off. Thus it seems reasonable that we'll choose a point on the utility possibility frontier as the most desirable outcome. But which of these efficient outcomes we find most desirable will depend on the philosophical lens through which we view the problem. We'll return to this in graph 29.3 after discussing some more issues related to utility possibility frontiers.